Hello all, welcome back. In this session, I'll take you through end-to-end process slash steps that we follow for predictive analytics. It will not be an in-depth session. Our main focus will be here to have a taste of Python programming language and how it works. At the end of the session, I'll list down certain features that distinguishes Python over Excel. While learning Python will be a great boost to your career, and we'll not learn the application building part of Python. We will just focus on how we can leverage Python for our data science work. So let's dive in. First and foremost, you need to download these two applications in your system. First is Python programming language itself. You can get it downloaded on python.org/downloads. The latest version available is 3.8.2. Once you download and install this application, you go to anaconda.com/distribution and download the same. This anaconda.distribution has got all the necessary libraries and packages that are used for data science work. You have NumPy, you have pandas, you have matplotlib, you have scikit-learn, you have TensorFlow. All the libraries that you require for data science job you will have in this Anaconda distribution. You download this app, download this application and install this. So once you download and install these two applications, one is Python and the other is Anaconda, you simply have to go to your run command and type in Jupyter Notebook. Once you open this Jupyter Notebook, you will have something like this opening in your web browser. After this, you need to go and click on New and start Python 3. Once you have this window popped up in your web browser, you can write in your code here and execute. For execution, you need to have run button or shift enter. For this session, I have already made some codes on sales data. So in this session, we'll see how we can predict sales based on various features we have in our data set. So first and foremost job in our data science process is to import all your libraries. So what does this library do? So you have library called NumPy. NumPy does all the mathematical calculations for you. You have library called pandas. This will do data wrangling, data preparation, data cleaning part of your data science work. For data visualization, you have something called matplotlib.pyplot and Seaborn. These two libraries are very powerful libraries for the purpose of data visualization. So we will write these codes and execute this. Once we execute, all these libraries will be installed, will be brought into this IDE environment. So once we have these libraries, we go and read our data. So to read our data, we have to define the path which will tell my Python programming language where to go and fetch your data from. For example, my data, my CSV file which is advertising.csv is residing in this path c://user/lenovo download advertising data. So I'll give this path to Python, and after giving this path to Python, I will I will name my data set which is advertising.csv. This is my file name. I will rename this file name into the variable that I wish to create. So I am creating this advertising variable. It's just like I am giving a name, a fresh name to my CSV file. And what I am doing here, I am doing pd.read_csv. I am telling Python that go in this path, you fetch this CSV file which is advertising.csv and read that file. After Python reads that file, I am telling Python that look, you print the top 5 row line item available in the data set, which is advertising.head. Head will give me top 5 rows of my data. So once I run and execute this command, we will have my outputs like this, which says I have 4 variables. I have TV, I have radio, I have newspaper, and I have sales. So all these 3, TV, radio, newspaper, these are my advertising spends that I have done, and based on these advertising spends I have my sales value. So whenever I do predictive analytics, I'll have 2 types of variables. One is predictor variable. So in this case, my predictor variable is TV, radio, and newspaper. These 3 features will cumulatively work to predict my target variable, which is my sales column. So these are the 2 categories of variables that are there in our data set. One is predictor variable, which is TV, radio, newspaper, and one is target variable, which is sales. So once we have read our data into Python environment, into Jupyter environment, and seen our data how it looks, now we do some kind of data inspection. So in data inspection, there are some steps that we follow, which I have enumerated here. First is we need to see how many rows and how many columns are there in our data set. So we do this with the help of simple Python command advertising.shape. Shape will give me how many rows and how many columns are there. So the output is 200,4. I have 200 row line items and 4 columns. Now I understand that in my data set there are 200 line items and 4 variables, which we saw above: TV, radio, newspaper, and sales. Once we have a sense of the shape, how many rows and how many columns are there, we need to see what are the data types. For this we have something called .info. So .info stands for information. So .info will give me what type of data is there in my CSV file. For example, TV is my float, which is an integer. Radio is my float. Newspaper is my float. So this will give me whether it's a string, whether it's a number, whether it's an integer, whether it's a boolean. We'll all go through in depth when we have our in-depth and detailed session coming up. After this, we need to have a basic statistical understanding of how our data looks. What is my standard deviation? What is my minimum value? What is my maximum value? What is my mean? What is my various quartiles? 25% quartile, 50% quartile, which is median, 75% quartile. So all this thing, a basic statistical sense we have to get before diving into our predictive analytics. For this we have command something like .describe. .describe, what it will do, it will give me these features for each and individual variables, which is count, mean, standard deviation, minimum, 25% which is my first quartile, 50% which is my median, 75% is my third quartile, and what is my maximum value. So now I have a little sense of how my data is spread. So till now what we have done, we have read our data, we have done some kind of data inspection. Now after data inspection, we dive into data cleaning stuff. So couple of examples I have taken here. We can do n number of data cleaning, because in real world scenario you will have messy data coming in your way. So 80% of your time gets involved in data cleaning and data preparation. So first thing, whether I'll have to check whether in my data set I have any null value or missing values. So this is a simple code that we have to run in order to find whether any column of mine have a missing value or a null value. In our case, for the sake of simplicity, there is no missing value or no null value. That is why when we execute this command, TV 0.0, radio 0.0, newspaper 0.0, sales 0.0, that means in none of the columns we have missing or null value. So after finding whether you have some null or missing values in your data set, we go and do some kind of outlier analysis. Again, outlier analysis we will study in depth when we have a full-fledged class on data cleaning, data preparation and machine learning. So in outlier analysis, what we do, there may be certain data points which will be very away from your normal data concentration, normal density of your data. So these outliers generally create problem while doing predictive analytics or while conducting any machine learning project. So we need to treat these outliers. How we treat these outliers? Again, we'll cover this in depth later on. Here we have to run this command, and once we run this command, we'll have something like this coming up in our output box. So these are my box plots. Box plots are a very good way of identifying your outliers. Now here we see there are two outliers in newspaper, one at 100th point and one greater than 100 point. So we have to treat these two outliers, but since we are not going in depth and in detail, we'll leave as it is. Again, when we go down, we will do some kind of exploratory data analysis. Exploratory data analysis stands for visualizing your data, exploring your data to have a greater sense of how my data is spread across various variables. In our case, these 4 variables. So I have done a little exploration on my sales data, how this is spread, whether there is any outlier or not. After this outlier analysis, there is something called correlation plots. These are my scatter plots. Now why we do this correlation plots? Now my sales value is dependent on 3 variables, that is TV spends, radio spends and newspaper spends. So I need to check how my sales is behaving with respect to each variable that we have in our data set. So for this we have plotted a simple scatter plot. So here we see now TV and sales, we have a good amount of linear correlation, that is when I'm increasing my TV spends, my sales are increasing. In case of newspaper, we don't have any linear correlation, we have scattered correlation. See, all the data points are scattered across. In radio, we have some sort of linear correlation, but again this linear correlation is not as strong as we have in case of television. So by this visualization we can understand that spends on TV is having a great impact on sales. So we can advise the management to increase my TV spends so that my sales gets increased, because in newspaper we see there is no linear correlation. So instead of spending a lot on newspaper and radio, we can advise them to spend on television. Similarly, we can see this correlation with the help of a correlation matrix. Generally, if we have this correlation plot, we get the sense of how my variables are impacting my target variable. But what is the quantum? What is the value at which they are impacting? We get the value with the help of correlation matrix that we have. Now here what we have seen my television spend is having a good correlation, good linear correlation with sales. Now here in this correlation matrix, this proves that in this television and in this sales, if you go here, we see 90% correlation, which is a very high and a very good correlation in case of TV and sales. So what we have seen visually here, we have seen in terms of numbers here. So what have we done till now? We have imported our data set, we have done some kind of inspection, data inspection, how my data set are having variables, how the spread is for various variables, TV, radio, newspaper, sales. We have done some kind of data cleaning. After data cleaning, we have seen the correlation part, how my correlation, how my predictor variables are associated with my target variables, and we have seen in terms of number as well. Now next to all this, we will have model building. So in model building, we will split our data set into training and test data set, and we do this with the help of a simple command like this. So what it does, it splits my entire data into training and test data set. Train size we have put it 70% and test size we have put it as 30%. In our machine learning project or in our predictive analytics, when we build a model, once we build a model, we have to test that model, how it is performing, the accuracy of the model. So the best part and the best way to do it is to split your data, the entire data that you have, into train and test data. So we build our model on train data, and once we have good accuracy on our train data, we apply that particular model on my test data and see whether my model that we have built on train data is performing well on test data as well. So it's a very good process of ascertaining the accuracy, the predicting power of your model. So once we split the data, we will build this linear model. So in our case, we have built a simple linear model. We'll have this code running, which will create a simple linear model. Again, what is linear regression? We will cover in depth in our future tutorials. So once we have this linear model, we'll see my model accuracy, my model summary. So all this kurtosis, skewness, all this probability, what is JB value. So all this we will cover in our later and future tutorials. So once we have this model built on my train data, we will visualize this linear regression. So linear regression, in linear regression we try to fit the best fit line, which is denoted by this red line. So once we create and fit this line, this will give me the best accuracy. And how to calculate this accuracy we will see down. So we have created this model, we have fit my model line in this data set, and after fitting this we will evaluate my model accuracy. So in case of linear regression we have something called root mean squared error, which is RMSE. So that error itself says that we need to minimize, since it's error we need to minimize the error. So your model will be targeting to minimize that RMSE. Again, this might be overburdening your head, but we will go and see in depth how this RMSE works and how we can better this RMSE in our future and later tutorials. So once we have this model evaluation done, whether I have created a model correctly or not and the accuracy power of my model, I will test this model on my test data set. So once I predict and apply that model on my test data set, I will have my R square. R square is the positive part, RMSE is a negative, RMSE stands for error part, and R square means better part. So my R square should be higher and my error, that which is RMSE should be as low as possible. So in this case, when we apply the model on my test data set, my R square is coming as 79%. And again, we need to visualize the best fit line. So I'll create a scatter plot and I'll visualize the point, the best fit line which cuts across all the points or nearby to all my points. So this is end to end steps that we follow in a machine learning or predictive analytics project. First is we read the data, second is we do some kind of data inspection to have a good understanding of my data, then we do some sort of data cleaning because you will have messy data coming in your way. After this we will do some kind of data analysis, exploratory data analysis, where we visualize the data. And so it's only when you visualize your data you will have a good sense of how your data looks like. After visualizing the data, we will go ahead and build our model. So first step in building my model is to split your data set into train and test. We use train data to create your model, and once your model is ready, we test that particular model on your test data and get my accuracy, which is 79% here in our case. So this is end to end a process that we follow. Now you'll say, why Python? You know, there is Excel you can take help of, there is n number of programming languages available in the market, but you go and see the trend of Python programming language. For the past 5 or 6 years, this programming language has shown a great deal of growth in terms of market share, in terms of increase in salaries, in terms of value addition. Nowadays a good Python programming language person earns a handsome amount in the market. So I'll list down some of the advantages that you can have over Excel. Now first and foremost is, with the help of Python you can read and work with almost any kind of data. Now there will be a situation you will have to do some kind of web scraping from internet. Now there will be some data which will not be available to you in form of CSV. You need to go on any website and do some kind of web scraping to excavate the data from the website that you are going into. So this web scraping is very easy in Python. I don't think so we have this kind of web scraping in Excel. You can work with any file, be it JSON file, be it CSV file, be it PDF file, be it text file, any file you name it, and you can read that particular file and work on that file in Python. No hindrance at all. In case of Excel, there is very much limitation as to what type of files you can read and work in your Excel application. Second most important part is automating and repetitive task. Now, for example, you go to a client, you do some kind of sales analysis on Excel. Now you go to a different client and that same client asks you to do a sales analysis. Now you will have to repeat the entire process again if you are working on Excel. In Python, if you have these codes ready and made for one client, all these codes, you run this code on dataset of one client, copy these codes, and for the next client you just need to import the data and execute and run this command. That's it. In less than 5 minutes you will have the output for your next client, for the second client, ready made into your hand. You need not bother and do the entire stuff again and again, which we'll have to do if you're working with Excel. Third is working with large data set. Many a times you see, if your data set, in your data set the number of row items increases to 50,000, 60,000, you do some pivot or some kind of data wrangling in Excel, it hangs up, it doesn't respond. So the working with large data set is a very I'll say not beneficial in Excel, but in Python you can work with any amount of data, be it in GB, be it in TB. So you have something like GPUs and TPUs coming up in your way, which is graphical processing unit, and TPUs tensor processing unit. You can work on any quantum of data that is available in your company or in your client's company. And nowadays if you do analysis, you have to work on data which is spread across 5 years and 10 years. You should not do on a 6 months data or 1 month data or 1 year data. So this will not give you a true picture and true pattern of any analysis that you do. So you need to work on a huge data set for 5 years and 10 years data set. So for that you need to have Python. Your Excel application will not work when you have those huge amount of data in your projects. Next is, whatever code you have written, if you want to share it with someone, you can do so in Python, but not in Excel. Python is an open source, it's free. You need not pay a single penny to work and install, download Python or Anaconda. It's totally open source, not a single penny. But in Excel you need to pay if you want to have a good functionality, good functions and good add-ins in your Excel. You need to pay some amount to Microsoft, but in case of Python it's totally free. Advanced statistics and machine learning capabilities. There is no competition against Python when it comes to machine learning capabilities. All the machine learning algorithms written in this world first comes into Python programming language, and Python works brilliantly in terms of predictive analytics and machine learning. You have advanced data visualization capabilities. You have libraries called Matplotlib and Seaborn, which are much more advanced and give you a good visualization experience than what you have in Excel. Truly enriching experience, data visualization experience. So these are some of the advantages that you have, that a Python programmer have over a person who is proficient in Excel. You can read and write any kind of data. You can automate your task. so that you can replicate the same thing to your client over client over client. You can work with large data sets. You can reproduce and share your data with third party, with your colleagues. It's an open source, free of cost. You have advanced statistical and machine learning capabilities and an awesome data visualization capabilities. So in this tutorial, in this session, we have gone through end to end process and steps that we follow in any predictive analytics with the help of Python programming language. I have taken you through various advantages that Python programming language has over Excel. In a days to come, Excel is going to capture the market. It is the leader in terms of data science work, in terms of machine learning capabilities, in terms of deep learning capabilities, and it's only the beginning. So if you need to learn data analysis and data science, you need to have Python in your kitty. There is no way out. There is no way out. You can learn Excel, but Excel will have a limited approach. You cannot do the amount of analysis, amount of predictive analytics which you can do in Python. It's awesome. So so in our next tutorial we'll go much in depth as to how my Python programming language works. We'll concentrate on various libraries, individual libraries. So in this case we had NumPy and pandas. So we'll concentrate and deep dive into each library and we'll learn the codes. Codes are very simple. The Python program, one of the main advantage of Python programming language over other programming language, which is R and MATLAB and SAS, is the code. The code is written in plain simple English. Any new beginner, new to programming language, can understand and can write this code. So see you in our next tutorial, next session. Till then, happy learning.